So in this video, we are going to be looking at resistors in series and parallel calculations. So we'll be considering 6 solid questions to explain this concept. 3 of the questions will be on resistors in series calculation, and the remaining 3 will be on resistors in parallel calculation. So sit tight while we begin the class. Now let's consider the first question. It says, a circuit consists 4 resistors in series, 5 ohms, 12 ohms, 8 ohms, and 15 ohms. What is the equivalent resistance? Alright, now let's use a diagram to illustrate this circuit. Alright, so this is what the resistor or the circuit diagram looks like, involving 4 resistors in series. Now, when is a resistor said to be in series? A resistor is said to be in series when they are arranged side by side in such a way that the same amount of current flows through them. Now, here is the voltage source. This is the voltage source where current flows out, right? So, this is our voltage. Now, current flows, okay, this is our voltage. Now, current flows out of this voltage source and moves upwards, okay? So this is the positive terminal and this is the negative terminal. Now current flows in this direction. Current flows in this direction and flows up. So you see now that the same amount of current flows through this resistor, comes out from here. Still the same current flows through this resistor, comes out from here. Still the same current flows through this resistor, comes out, and then still the same current flows through this resistor until it comes out, okay, until it comes out and flows back into the source, and the circuit continues like that. So when the resistors are arranged side by side such that the same amount of current flows through them, they are said to be in series. Now when resistors are in series, simply their equivalent resistor simply means the sum of the entire resistances in series. So in this case, since we have up to 4 resistors in series, it means equivalent resistor or resistance, which is R equivalent, is now going to be equal to the sum of the individual resistances, R1 plus R2 plus R3 plus R4, up to the total number of resistances that are connected in series. So in this case, we have 5 ohms plus 12 ohms plus 8 ohms plus 15 ohms. So this simply implies that for this very first question, equivalent resistance R equivalent is going to be equal to 5 plus 12, that's 17, plus 8, that's 25, plus 15, that's 40 ohms. So the equivalent resistance is actually 40 ohms. So that's it for the first question. Now let's get into the second question. Now let's consider the second question. It says a 12-volt battery is connected to a series combination of 3 resistors, 9 ohm, 20 ohm, and 25 ohm. Calculate the current flowing through the circuit. So as usual, let's start by drawing the circuit diagram. Alright, so this is what the circuit diagram looks like. So we'll have 9 ohm resistor, 20 ohm resistor, and then we'll have 25 ohm resistor. And once again, this is a voltage source. And once again, this is a voltage source. Now remember, in the question it says a 12-volt battery, so which means the voltage is actually 12 volts. So this is 12 volts. And I said that current flows from the voltage through the circuit. So just like I illustrated earlier, current flow will be in this direction. So when current flows, you have it in this manner. So this is what tells us that this is a series connection, because the same current flows through all these resistors. Now when you have a question in this manner, the first thing you do is to find the equivalent resistance of the 3 resistors connected in series. So for these 3 resistors, remember, R equivalent becomes what? The sum of the 3 resistors. So R1 plus R2 plus R3. So R equivalent, which is the equivalent resistance, becomes, you sum them up now, 9 plus you have 20 plus you have 25. So this simply implies that our equivalent resistance will be equal to 9 plus 20, that's 29, plus 25, that is 54 ohms. So the equivalent resistance is actually 54 ohms, and you have this. Now, having found the equivalent resistance, question is asking us to find the current that flows through the circuit. Now, to do this, you simply employ Ohm's law. From Ohm's law, you have that V, which is the voltage, is equal to product of current times resistor. So V is equal to IR. So from here, if I make current subject of the formula, I'm going to be having what? Potential difference V all over resistor. Okay, so where this resistance is simply my what? Equivalent resistance. So this simply implies that for this given circuit and for this given question, the current flowing through the circuit is going to be equal to the voltage there, or the potential difference is the voltage source given in the question as 12 volts. So we simply have 12 divided by the equivalent resistance, which is 54. So this simply implies that the current flowing through the circuit is going to be equal to, so let's find 12 divided by 54. That simply gives us 0.22, approximately 0.22 ampere. So our current is actually 0.22 amp. Okay, so this is the value of the current flowing through the circuit. So let's get to the third question under series connection. Now let's consider the third question. The question says, in a series circuit, the total resistance is 60 ohms. If one of the resistor is 20 ohms and the other is 40 ohms, what will the total voltage across the resistors be when the current is 2 amps? Okay, so in this question, I'm not going to be drawing diagram because I'm sure by now you should be used to drawing the diagrams. But something is very peculiar here. You were given that in a circuit, in a series circuit, the total resistance is 60 ohms. So that means our equivalent resistance, R equivalent, is already given to us to be what? 60 ohms. Now they further went ahead to say, if one of the resistor is 20 ohm and the other is 40 ohms. So remember, you're given two resistors here. So just to prove this equivalent resistance already given to us, remember R equivalent should be what? R1 plus R2. So the first resistor there was given to us as 20 and the next was given as 40. So 40 plus 20 simply gives us what? 60 ohm. Okay, simply gives us 60 ohms. Alright, so which is how this was already calculated in the equation and given as 60 ohms, right? Okay, so we are given current. Now they say, what will the total voltage across the resistors be when the current is 2 amps? So we are given current, which is I, was given to be equal to 2 amps, and we are asked to find voltage across the resistors, V. So once again, you employ Ohm's law. From Ohm's law, recall V is equal to IR, and we are looking for what? V. So this is going to be equal to, current there is 2. Now the equivalent resistor, R here becomes equivalent resistance, and it was given there as 60. So simply 2 times 60. So this simply implies that the voltage across that given circuit is 120 volts, and that becomes the answer to the third question. Alright, so the remaining 3 questions, we're now going to be focusing on resistors in parallel calculations. Alright, now this question says, find the equivalent resistors, find the equivalent resistance of a parallel circuit containing 3 resistors, 6 ohm, 4 ohm, and 12 ohms. Okay, so I'm going to be drawing the diagram to explain the parallel connection. So when resistors are connected in parallel, this is what the diagram looks like, where this once more is our voltage source. So this is our voltage, This is our voltage. Okay, now resistors are said to be in parallel when they are connected in such a way that different amount of current flows through them. Now let's explain this. Let's say current flows out of the source. You have your direction. Now when this current flows here, once it gets to this branch, once it gets to this node, now this is called a node. Every branch in a circuit is called a node. It can also be called a branch. Once you get to this node, some of the current flows through this resistor while some flows up here. So you see that what is now coming out from the circuit has been splitted. Some flows here while some flows here, and that one that flows to this point, once you get to this node, again it diverts. Some also flows through this resistor while some move here and flow through this resistor. So which means there are different amount of currents flowing through them. So if you have resistors arranged in such manner that different intensity of current flows through them, then they are said to be in what? Parallel connection. And for parallel connection, to find your equivalent resistance, you're going to be taking the reciprocal of each of the resistors. So this case we have 1 all over R equivalent to be equal to 1 all over R1 plus 1 all over R2 plus 1 all over R3, depending on the total number of resistors you have. Since we have 3 here, that means it remains 3. So when they are connected in parallel, their equivalent resistance is simply what? A reciprocal of each of them. So we have 1 all over R equivalent to be equal to 1 all over R1. R1 there is 6, so 1 over 6 plus 1 over R2 is 4 plus 1 over R3, which is 12. Now in this case the LCM remains 12, so 1 over R equivalent is going to be equal to, LCM is 12, so 12 goes into 6, that's 2. 2 times 1 remains 2, plus 12 goes into 4, that's 3. 3 times 1 remains 3, plus 12 goes into 12, that's 1. 1 times 1 remains 1. So this is actually what? 2 plus 3, which is 2 plus 3 plus 1, that is actually 6 all over 12. So this simply implies that 1 all over R equivalent is 6 over 12. Therefore, to find the equivalent resistance, you simply take what? The reciprocal of both sides, or simply invert. I had 1 over R here, so if I'm not inverting, it becomes R equivalent all over 1, which remains R equivalent. Therefore, I will also maintain the same at the right hand side of the equation. Inverting becomes what? 12 all over 6. Okay, so this simply implies that R equivalent is equal to 2 ohms. So for that given circuit, the equivalent resistor is simply 2 ohms. Okay, so that's it for this first question. Now let's go to the next question on resistors in parallel calculation. Now the next question says a 24-volt battery is connected to a parallel circuit with 2 resistors, 8 ohm and 16 ohm. Calculate the total current supplied by the battery. Once more, let's draw a diagram to illustrate this question. Okay, so this is what the circuit looks like for 2 resistors connected in parallel. This is 8 ohms, this is 16 ohms, and this is our voltage source. And from the question, it was given that the voltage source is actually 24 volts. So the voltage source is 24 volts. Okay, so I've already explained why this is said to be in parallel. So since we now understand that this is in parallel, we have to find what? First, the equivalent resistance, and that is going to be equal to, you remember, since it is in parallel, equivalent becomes reciprocal. So 1 over equivalent is equal to 1 over R1 plus 1 all over R2, depending on total number of resistors you have. So this is actually 1 all over R equivalent is equal to 1 over R1, there is 8, plus 1 all over R2, there is 16. So 1 all over R equivalent is going to be equal to, LCM between these two remains 16. So 16 goes into 8, that's 2. 2 times 1 is actually 2, plus 16 goes into 16, that's 1. 1 times 1 is actually 1. So this is going to be 2 plus 1, which is 3, all over 16. Okay, so this simply implies that 1 all over R equivalent is equal to 3 all over 16. And if we go by inverting to find R equivalent, so simply send R equivalent up, bring 1 down. That means you're also going to do the same thing at the right hand side. Send 16 up, bring 3 down. So if you do that, therefore you're going to have R equivalent to be equal to 16 all over 3. So let's find the value of 16 over 3. So 16 over 3 simply gives us approximately 5.33 ohms. 5.33 ohms. So the equivalent resistance is simply 5.33 ohms. But the question is asking us the current flowing through the circuit. For this case, you simply make use of the Ohm's law. So from Ohm's law, remember, V is equal to IR, where I is the current. So from here you can easily make current subject. I is going to be equal to what? Potential difference all over equivalent resistance, and this is going to be equal to the voltage source there was 24, so that's our potential difference, 24 volts divided by equivalent resistance obtained is 5.33. So this simply implies that the current flowing through the circuit is going to be equal to, so let's find 24 divided by 5.33. that simply gives us 4.50 approximately. So we'll have 4.5 amps. Okay, 4.50 ampere of current is flowing through that circuit. Okay, so one more question and then we're going to be done with this session. Alright, so let's consider the final question for this session. It says, if a parallel circuit has two resistors, 30 ohm and 45 ohm, and the total current is 2 ampere, calculate the total current flowing through each resistor. Alright, so with the knowledge of the circuit diagram already laid out, I'm not going to be drawing the diagram for this question. So let's pick out all our parameters. So we're given two resistors, R1 to be equal to 30 ohms, and we're given R2 to be equal to 45 ohms. We are given total current to be equal to 2 ampere, and we are asked to find the current flowing through R1, call that I1 unknown, and current flowing through resistor R2, call that I2 also unknown. Now, in order to answer this type of questions, the first thing you need to do is first find the equivalent or find the voltage which is supplying this 2 ampere current. Find the voltage that is supplying this 2 ampere current to the circuit. And in order to find that voltage, it means you need to find the equivalent resistance between R1 and R2, then utilize the Ohm's law to find that voltage. Alright, so for parallel connection, you remember 1 all over R equivalent becomes 1 all over R1 plus 1 all over R2. So this simply implies 1 all over R equivalent is now going to be equal to 1 all over R1 there is 30 plus 1 all over R2 there is 45. So the LCM here, so 1 all over R equivalent is now going to be equal to, now the LCM here has to be the multiple of the two, right? So simply 30 times 45, that gives us the LCM. Let's obtain 30 times 45. So you have 1350. So the LCM there is simply 1350, which is 30 times 45. Alright, so 1350. Alright, so 1350 divided by 30, that gives us 45. 45 times 1 remains 45, plus 1350 divides 45, that gives us 30. 30 times 1 remains 30. Therefore, you have that 1 all over R equivalent is going to be equal to 45 plus 30, that is 75 all over 1350. So once more, if I take the reciprocal of both sides, or simply inverting both sides, I'm going to be having R equivalent to be equal to 1350 divides 75. So this simply implies that the equivalent resistance, which is providing that 2 ampere current, is going to be equal to 1350 divides 75, and that gives us 18. After obtaining our equivalent resistance, the next thing is to find the voltage, right? So from Ohm's law, you recall that V is equal to IR. Now the current is given as 2 ampere. Equivalent resistance now has been obtained as 18. So this simply implies that the voltage supplying this current is going to be equal to 2 times 18. That gives us 36 volts. So this is the voltage supplying that 2 ampere current. With this now, you can now find the individual current flowing through each of the resistors. Okay, so to do that, for R1, for the first resistor, for R1, V is equal to IR1, right? So we'll find, V is going to be I1 R1. Okay, so to make I1 subject, therefore I1 is now going to be equal to what? V all over R1, and that is equal to, V is obtained as 36, so you have 36 divides, in the question the first resistance there is 30, so let's just check. R1 there is 30, as can be seen, so 36 divides by 30, this gives us the intensity of current flowing through R1. So this implies I1 is going to be equal to, let's obtain 36 divides 30, that gives us 1.2 ampere. So you have 1.2 ampere. So this is the current flowing through the first resistor. For R2, which is the second resistor, for R2, same thing, V is going to be equal to I2 R2. Therefore, you make I2 subject, that becomes V all over R2. So this is equal to, V remains 36, R2 was given in the equation as 45. So this simply implies that I2 is now going to be equal to, let's obtain 36 divides 45. That simply gives us 0.8 ampere. So you have 0.8 amp. Now to confirm the total current, remember total current is going to be what? I1 plus I2. So this is actually 1.2 plus 0.8, and that simply gives us what? 2 amps, which was given to us in the equation. So which means our solution is very much correct. Alright, so that will be it for this video. In the next video, we are going to be breaking down this circuit. We are going to be breaking down this circuit in the next video, right? Because this is also a combination of resistors in series and parallel calculation. So we are going to be breaking down this circuit in the next video. I'm sure you don't want to miss out on that video, so do well to smash the subscribe button right now, turn on your notification bell so you don't miss out on this video when it drops. In the meantime, do well to like this video, share to your friends, comment nicely, and I will see you in the next video. Thanks.